you use rosin to harden the pitch?
Yes.
Okay. Because boy, you had a lot of different pitches in there.
Yeah, I blend my pitches.
Okay.
I thought I should have given you my pitch tester too.
Oh, really?
Simple thing. Yeah, it's just a pointed 3/8 inch or 1/4 inch steel rod with a weight on top, and you time it for how long it takes to sink a certain distance into the pitch.
Oh,
and
wow.
That tells you what the pitch is, what the pitch hardness is, and you can look it up and decide whether you're doing it too hard or too soft. It does change what the strokes give you if it's too hard.
I'm going to try to do a star test on that mirror. You know, I went out in the backyard last night, Jerry, and my wife, she loves gardening. And my backyard now, I have a view of zenith. Everything else, there's bamboo on one side, trees on the other, the canopy of oak. I mean, it's just amazing. And I don't want to go in the front. I don't want to drag that downstairs.
So just lay on your back with binoculars and everything's cool.
No, I want to test that 8-inch. I got it in the mirror. I got it in the mirror cell and everything. I'm going to take it out and I checked it on the moon. It looks pretty cool. But Tom said that doesn't count because
everything looks good on the moon.
Yeah.
Matter of fact, Tom used to call things that only look good on the moon, he'd call them a moon scope.
Yeah.
And they were off by well over the quarter wavelength. So
now I think Bob Fees, we had a couple of guys. I think you sent me a link or Chuck did. I'm not sure, for a guy up in Montecito that wanted me to go out and collimate his scope. I did that a while back, and I showed that all to you. And he was the last guy that told me that Bob Fees is still coating, or he just started coating mirrors again. So he's back in business.
Okay.
And, so that'll be good. Should I start, Jerry, by repeating what we did on Monday about the star testing during the day, or should we just let that go for the time being?
On Monday,
we talked a little bit about star testing a mirror during the day.
Didn't we do that during the 11 o'clock thing?
We did.
Yeah, so that's already recorded.
Oh, okay, all right. Then let's move on.
Yeah. Okay. Well, let me show you a picture. Oops. See that?
Yeah.
This is the inside of my carbon fiber tube.
Oh.
There's a garden fence back there out the other end of the tube. This is the butt end this is the front end of the telescope. These are 2 holes. There's another 2 up there for the spider. And these weights are in there because we've been having some wind lately, and the carbon fiber tube weighs almost nothing. So it's outside. And I'm installing flocking material from Protostar in there.
That's what I was wondering what that was. And Jerry, you said it has kind of almost like a velvet kind of feel to it.
It's kind of a real short velvet of some type, made out of artificial fiber. It's very tight, and it gives less than 1% or some fraction of 1% reflectivity at very low incident angles, like 1 degree or so. And it's the same thing that television uses inside their NP127 and 101 scopes.
Oh, okay, that's what I got. That's what I got in mind.
So I have this in my other scopes, in my 10-inch and my 12.5 inch, and it makes a big difference.
Are you gonna? Is it have a self-adhesive on one side?
Yeah, it's self-adhesive. You just peel the back off. I cut it into 4-inch wide strips, and then I roll the strip in lengthwise and pull the backing off as I lay the felt down.
Oh, okay.
It's easiest to do this in the 18-inch. I did it before on a 10-inch, and I did it in a 12-inch. And the 12-inch was F6. It was really hard to reach the center. I couldn't reach with my hand. I had to have a little roller on a stick I pushed in there.
Right. I was going to ask you that. how you reach the middle.
How do you keep it from skewing as you go down the line there? Are you're gonna put another piece right up, butted up against that one there? How do you keep it from skewing off?
This is actually 3 pieces.
Oh,
3 long strips. They're 6 feet by.
So you're not going the full length.
Yeah, see, there's the seam right there.
Yeah,
I got you. I see.
Yeah.
Oh, so
yeah. Go ahead.
4 inches. This is okay. So I can see the seam now that I look up there. Okay, I got you.
Yeah.
So the fact that they're not so wide, and then do you have a problem getting one seam butted up against the other one when you?
I don't try to do that. You can have up to a 1/8 inch overlap.
Oh, okay.
I go from And the thing I want is I want no wrinkles in it, and that's the hard part.
That's the hard part. Yeah.
Yeah.
And that's why you're keeping the strip width so short.
Mm-hmm.
Yeah.
Boy, that would be a bear to have if you took the adhesive off the entire strip and had somebody hold one end and you're holding the other. But that would be a bear to get.
Oh, I depend on. It would touch so many places I didn't want it to touch, and then we'd ruin the glue trying to get it off and weaken it and stuff. So, I peel the paper off as we go.
Okay. Yeah, that's the best way. When I do the big prints, that's what I do. As I peel it off, normally, unless let's say, for example, I screw up and I want to use the other side, which doesn't have the glue on it, then I get that glue, that 3M type of glue, and I just put that stuff down.
That's to mount your picture on a cardboard thing or something, or back.
Yeah, to put it on Gatorboard.
I used to use, I forget what the brand name is, but it was from Kodak, but it was basically a wax glue. And you put the picture down, then you put a towel over the picture and use a hot iron, clothes iron to activate the glue.
Yeah. This works pretty good. But what I do is I roll the print up on a pipe.
Yeah.
Like let's say about a 2-inch pipe, and I lay it out diagonally, because if you do it diagonally, there's less chance of a wrinkle. But of course, what you've got here, you can't really do that. You've got to lay it out in one strip.
Well, some people take a long piece of dowel and they roll enough fabric to go around the entire inside, and they stick it in there, and then they just roll it up and over.
Yeah,
that's too scary. I've never tried it.
It seems scary. The problem would, I think, be getting it to keep it from wrinkling, especially in the middle, because you can't really apply that much force there. See? Yeah,
that's true. Now with 6 foot, I only have to reach 3 feet in from each end. So so I can reach that with a good clearance to press down.
So you're just doing 3 feet at a time, then you're not going the full distance. Is that what I'm hearing?
No, I have a strip that's the entire length of the tube, 6 feet, but I can reach 3 feet from either end.
Gotcha. And then you're using the back.
Yeah.
Boy, Dick, I've seen this tube out at Jerry's house, Dick. It's impressive. It doesn't give it this image here doesn't give it full justice. I mean, you should see it. It's a big tube.
Wow.
You can reach in and you could get your whole body in there for pretty.
It's 22 inches in ID.
Wow.
Yeah, it's impressive. It's really impressive.
And the outside
surface.
And the mirror size is 20?
18.
18, okay. So that cell takes up quite a bit. Okay.
Yeah.
Well, you got 2 inches on each side?
2 what?
You have 2 inches clearance on each side of the tube, right? It's 22, so you got 2 inches clearance instead of 1 between the mirror and the.
Yeah, between the mirror and the tube.
Okay.
That's a lot of clearance. The mirror cell takes up about 1.5 inches of that.
Oh, okay.
Is there any baffling in there at all that you're going to be
working
in? Okay.
No, I gave up on baffling a long time ago.
Did you?
I made it in graduate school in order to get access to the machine shop at UCLA. I had to make a project from start to finish and show everybody I knew how to machine. Otherwise, I was going to have to take a course in it.
Mm.
And so I made a 90 millimeter F11 refractor. And I made about 5 baffles that fit down in it. And I carved them out of chunks of aluminum that were like a 1/4 inch ring around. And then I hollowed it out until there was a web over the end that I cut a hole in. And the hole was varied as you go down the tube. And that was the baffle. And then I had a set screw in the collar so I could just put it wherever I wanted in the tube. Because a 90 millimeter tube is not very easy to reach down inside when it's long like that. So that was the last baffling I did. I cut a set of baffles for 12.5 inch tube, but I read about the air currents and how the baffles will force the air currents coming from a mirror that isn't completely cooled yet. It will force it out into the light path, and it actually makes it easier to get bad seeing. So I started with, then I got this flocking material and put that in, and that worked great.
Now, I think I asked you this before, Jerry. Is it, if you have heat coming off your mirror and the baffling is forcing it into your light path, and it's screwing up your image.
Yeah.
What about the fan? Will the fan do the same thing?
No, the fan, it depends all on your flow. You want laminar flow. You don't want turbulence. It's the turbulence that screws up your light path. If the flow from the bottom of your mirror, if there's no baffles in the tube, the mirror, the air will flow up through the tube in laminar. There won't be any turbulence. So it won't screw up your, but most of those fans, when you have a fan at the bottom of your tube, like held on rubber bands behind your main primary.
Right.
You want that fan to suck air out of the tube, not blow it in. Because it's going to be on the bottom of the tube down near the ground. It'll pick up dirt and throw it up into your tube. So you want it to pull air down the tube and then suck it out the bottom.
Oh, wow. You know, I got to check, make sure that's what I'm doing with mine. No wonder maybe that's what's happening to my mirror. I got all kinds of stuff on my mirror. I was wondering why.
Rule number 1 is never look down at your mirror or down the tube with a flashlight, because all mirrors look like they're an archaeological dig.
Yeah, that is for sure.
Yeah.
Somebody saw mine at the beginning of a star party and they said, "What is that?"
Yeah.
And I said, "That's a mirror that needs to be recoded."
I don't even use a fan, and mine looks like crap, but it still does great. So.
Yeah.
Well, there was a story guys told at one of the workshops years ago about a big scope up north that's on the ocean, and a famous scope, and the mirror got a bunch of crud on it from the ocean currents, and so they decided that they were going to clean it off. And so they cleaned the mirror off, and the scene was worse on the mirror. And the guy was saying, "What the hell's that about?" And so they found out from that. You remember that, Jerry? We were talking about.
I'm not familiar with that.
Oh, it was a great story, because they found out that some of the coatings that they put on mirrors, I think they got a lot from that particular story, that they had. They put some coatings on mirrors that would give them a much better scene. But this one was right next to the ocean, and I guess the salt air and some of the salt air got caked onto the mirror. But when they took it off, the scene was worse. So I'll try to find out what that was. I think Tom Whittemore or Mike Chimnick remember that story, one or the other. So I'll try to find it. But it was a great story. Famous scope up north.
The only scope I know up there is Mount Lick's 120 millimeter.
It might be Lick, but I'm not sure.
There was one up in Vancouver, British Columbia, 78-inch telescope.
I think it might be the Lick mirror, but it was, I'll ask Tom Whittemore and see if he can remember that.
Okay.
But it was a great story.
Huh. Yeah.
Okay.
Well, the moral of the story is don't clean the mirror.
Yeah.
Unless you're planning on getting it re-illuminized or whatever.
Yeah, mine just looks like crap. I mean, the last time I cleaned it and I looked at it, I just said, man, it looks like nothing happened. I mean, it's really oxidized, and this is kind of gross, but when I talk, there's a certain, especially at outreaches, there's a certain amount of spray in my talking. I'm talking too loud, and the saliva gets mixed in the air, kind of aerosol. It aerosols over the mirror, and I found a few little specks of saliva on my mirror, and it ate into the coating. And I was, oh my God.
Well, you need to have some kind of wrapping around your telescope to keep you from spitting on the mirror.
Yeah, exactly. I mean, you know, I have the light shroud on it most of the time, but this was when I was putting it together and explaining to people how I built the thing. And next thing I know, I looked down and I went, oh my God, how gross is that? You know, so, you know, I gotta, there are people that spit when they talk, and I think I'm one of them. I found that on the mirror, and it proved it to me. So anyway, enough.
You know, a while ago, Gary Peterson and I, he got a old cave 8-inch f8 bequeathed to him, and it was in terrible shape. There was even mud on the mirror, on the main mirror. And we took the mirror out and we soaked it upside down in a plastic square dishwashing pan, and with a teeny bit of detergent in there, and we soaked it for like a day, and then, you know, stirred the water a little bit, and we didn't do anything else to it. And by the time we got through with it, all the mud had settled off the mirror, and the mirror looked almost brand new. And so we never had it recoated. We just put it back in the telescope. It worked great.
Oh, wow. You know, Jerry, I'm going to have a talk with the guys in the workshop. I was bequeathed years ago a cave 12-inch f6, I believe it is. I think I sent you guys pictures of it, and I'm probably never going to build a scope with that. So maybe we can get together and figure out what we can do with that. Maybe we can sell it and take the funds and put it in the club funds.
Maybe. You know, those cave mirrors are what's called standard mirrors, which means the aspect ratio is 6:1. So
It
for
is.
a 12-inch mirror, 12.5 inch, it's going to be a little over 2 inches thick. That's going to be a lot. That's a lot of glass. So
It's heavy.
My 18 is only 1 3/4 inch thick.
Yeah.
So that's, I don't think you're going to find many takers for using that. F6 though is not bad. But
how much is yours weigh? How much is yours weigh, Jerry? You're 18.
The glass itself weighs 32 pounds.
That's not bad.
No, it's not. So,
I think
dig it up. You know, Joe Doyle had a 12.5-inch cave that he was trying to sell when I first joined the club about 2000. And I went over and looked at it. The whole scope weighed about 100 pounds. I could just.
It was 100 pounds.
Yeah.
We called it the Beast. That's the one that he remade.
Yeah, that's his 12-inch scope.
Right.
But he has an 18-inch now, or 20-inch, one of those two.
He has an 18. He has a what is that? A star. God, what's the name of those? From Obsession.
Oh.
He has an Obsession 18, and the mirror that he has in that, I can't remember what mirror he got it from. It started with a T, but he found that it wasn't. The figure on it was horrible, so he sent it back to get redone. And the guy took a long time refiguring it, sent it back, and it was still wrong. So he was pissed. So I think he finally got it back, and it's pretty good now. But that cave that he's got is just like mine.
Yeah, but I don't think that cave is a cave. It says cave. There's a plaque on the tube that says cave, and it's got the mirror and the focal length right, 12.5 inch. I think it was f6.
Yeah.
But when you take the mirror out and look at it, cave always etched the actual maker and the date and the focal length and all that information on the side or the back of the mirror. And there's no marks on the mirror at all.
Well, the one I should have sent you this. I tried sharing one time, it didn't work, but I have a picture of this cave somewhere in my photos, and I sent to the registry for cave mirrors. I sent this to the guy who showed him.
Yeah.
And the date on it, the last digit of the date was scratched out and then rewritten over. And the guy sent me a lengthy letter back and said, "Oh yeah, that's that, and that number is supposed to be this." And he said what happened is that he did that is a cave mirror, and he said that it was done like over Christmas, and so he missed the year on it when he put it on. He put the wrong year. So he scratched it out and put the date on it. I'll send that to you, Jerry. We can share it next week.
Okay. Yeah.
So yeah, but there's guys.
I'm
sure there's guys out there, Jerry, that would buy that thing just because it's a cave.
Probably.
Yeah.
Of course, they're getting fewer, far between now. Cave is old scope.
Yeah, but I mean, this guy was pretty. He was happy to hear that that I had one, and now he's on the registry. It's been documented. It's on his website. So I don't have to prove to anybody. It's already on there because I sent him images of it and he said, "Yep, that's the real deal." So it does probably need to be recoded, but we'll talk sometime to the guys in the club, see what they think.
Okay.
All right. Sorry about that. I got sidetracked.
Okay.
This is
all this time we've been talking, I didn't notice that Mike was waiting to get in.
Oh no.
Uh-oh. There he is.
Hi.
Hi,
Hi.
Sorry. How long have you been waiting?
not long, not too long.
Okay, good. We were engaged in a conversation and I didn't look at the waiting
That's
room.
okay.
Sorry. I gotta figure out how to get waiting room so it doesn't work.
That's as far as I've got with my planetary imaging, lunar imager. I've got the 4x power mate on there. I've got it all the way up to the camera side here. I've got a Bader click lock 2-inch guy here. And then this is the eyepiece guy right here. Here's the flip setup.
Yeah.
The only piece that I need is the nose piece. And that one's got a 2 to 4 week lead to get that nose piece, that 2-inch nose piece. These are I think it's S52 to 2-inch is what I need, that adapter. And that one's got a 2 to 4 week lead that they're back ordered on those. So there's always something that I can't get.
Now, which end does the camera go on?
The camera goes on this end here. See, this is all the way up. This is the band.
So you'll be looking with the eyepiece at an unmagnified view, but the camera will see a magnified view.
Yes.
So you might.
So in other words, you have to choose an eyepiece that's appropriate for whatever magnification. And that's something I still don't have down. I've got some eyepieces and I thought, well, I'll try what I got, first, but I don't have any reticle eyepieces. What I kind of wanted to do is get an idea of what kind of focal length eyepiece I want to have first, and then I can kind of go, okay, I can get a reticule eyepiece that will fit that. That's kind of my plan right now.
Okay.
So to do that.
It seems to me that if you got a reticle eyepiece and you could ensure that the coaxiality, this eyepiece looks exactly at the same spot as your camera does, just getting it on the crosshairs probably is adequate.
Yeah, I think so. I haven't tried it yet, but I believe that's going to probably end up being the way it works. So, now to just if I was just to use it to look at the moon or to photograph the moon, I would need to use, let's say, the movie setting on my camera, right, to do that, and then some kind of a program that would, let's say, like Auto Stacker, to select
Yeah, you want to capture a video, but you want to use a DSLR camera on there. You want to use a video camera.
Okay, you're using a Canon, correct?
Yeah, they got a video mode in there.
They
right?
do, but it's
Yes,
not going to
and-
work well.
What I would use, if you don't have it, it's Backyard EOS has a planetary mode. And with your camera is new enough to have the live view. So,
Yeah. It does have that.
okay, so when you think about it, using that, you could readily, for one thing, could really, it's got its own crosshair and reticle that you can move around. Okay, but you could use that to ensure that to check that your camera is centered in the same place that your reticle eyepiece is looking at. Okay. Another thing too is with the live view, you may wind up not needing the reticle eyepiece if it's got a wide enough view.
Yeah, that's true. Yeah, I was thinking more or less with the reticule is if you were to, at 4 times magnification, you're going to be looking at just, let's say, a portion of the moon. Or let's say, for example, if you had Jupiter or something like that, just to center it up, you might get yourself into a situation where without that eyepiece, you'd be.
You're using it on your refractor, correct?
Yes.
Okay, so it's what, 1500 millimeters or something like that?
It's 660 millimeter focal length. So if you put the ×4 guy on there, you're looking at it's up there.
Well, yeah, 4 times.
250.
It's about, you said 800 millimeters, or is it 600 millimeters?
660 millimeters is the 100.
Okay, 7 times 4, 2800 millimeters about.
Yeah.
Okay.
Yeah. 28.
I would tend to think that maybe, just maybe, this is the experiment I would do, tomorrow night or tonight. Just put the camera on with the 4 times Barlow on your telescope and get it focused and see how much of a hassle it is. Especially tomorrow night with the moon. You could definitely see whether you have a wide enough view that if you get it kind of close enough, okay, you'll be able to.
It's worth a try.
Yeah,
Yeah.
because of the fact that with my finder scope, when I had issues with my Misu and I didn't get my pointing quite right, I found that you could get it pretty close to where it might not be centered. Then you screw it in there, and then you're done.
Right. Well, yeah, and then the other thing too is for mosaicing, let's say the lunar scape, you probably want to have something there where you can accurately center it.
I don't think you're going to need a reticle in your wider field eyepiece. Because the camera is gonna probably just be centered very well anyway. And you can certainly tell when something you want is in the field of view, in the center of the field of view. So this just lets you see the wider field, so you're not searching through the narrow field camera all night.
And with Backyard EOS, you can drag around that center.
Yeah, those
Anywhere
square, the
in
rectangle.
the thing that and just let it stay there. And so if it's off, you knock it off or something like that, just getting it centered. So you have what, 6 micron pixels, correct, on your camera?
Yeah, about 5.75. Yeah.
Okay.
Yeah, that's.
So I can't calculate off the top of my head what your resolution.
If you're using, Dick, if you're using a 4X PowerMate and your focal length is 660, is there a multiplier, like a 1.6 multiplier with the camera?
That's what the 4 is. It's the multiplier for your focal length.
Yeah, this does.
So it would literally be 4 times 660?
Yes.
Okay. So you're going to be about 2,800 millimeters for the
Yeah.
moon.
2640.
What is it? 2640?
2640.
Yeah, I haven't seen one of those
41.
calculators in a long time. I don't even
Yeah,
know if I
my
still got mine.
HP 15 calculator, the penultimate calculator functionality, size, power, and
Is that a 15C?
15C.
Yeah, that's exactly the same one I had.
I mean, for what it is, the only thing it lacked is a program reader with a,
Oh, yeah.
they used to, some of them you could read stripes and program it, but anyways,
Yeah, a little magnetic chewing gum strip.
yeah,
Yeah.
right, yeah, it didn't have that,
Okay.
but believe me, the batteries on here last like 5 years or more. I mean, I'm gonna be buried with this.
I have an HP 41C in software on all my different laptops and computers and iPads.
Oh, funny you should say that. I've got a 15C on
Yeah.
my iPhone.
Oh, okay.
So who makes that, Mike? That calculator?
HP.
HP. Yeah.
Oh,
Yeah.
okay.
Yeah, it's got the reverse Polish notation, which all the TI people hated. Because, but fourth programmers understood it implicitly.
Yes.
Yeah, yeah.
So
I
for
learned
support,
about that when I was a kid, going to a restaurant, the old push down stack on the dishes when you used to hold the dishes from the kitchen. First in,
now
first
for
out.
support stuff for, let's say, a lunar shot, I need to have bias and I need to have flats, right? That's it. That's pretty much it, at least for lunar stuff. Most of your planetary stuff, I wouldn't think you need to have.
Yeah,
dark.
it's going to be short enough that the noise is
Yeah.
probably, thermal noise.
And it's going to be bright enough. You may not even need bias.
Yeah. But the thing is that you're going to be taking a lot of shots each time you do it. Don't just take one or two or five.
No.
No, and I was thinking about using something like that auto stacker program to select out the frames that it will stack, as it has some kind of a multi-point
Yes.
registration feature, which I think
that's very advantageous. It'll straighten out the wiggling due to seeing.
Yes, right,
Yeah.
the seeing.
You want to start with a video that's between 500 and 1,000 frames.
Yeah.
Okay. All right.
And it has the ability to judge good from bad frames too,
Right.
I believe.
Oh, you shoot a video.
What's that?
You shoot a video. I didn't
Yeah.
know that.
Video.
Well, I
Oh.
think it also has the ability to use single frames, in a sequence, but an
Yeah.
AVI or an SER is the way to go for.
Yeah.
I think an SER is if you're going to use WinJupos
Okay.
for something. For like
Yeah, and I
people-
hear you don't need to have high bit resolution either. The
Hi,
some
Bruce.
of the best images I've made is with a webcam, so
yeah.
on
Yeah.
a good day, it's like 6 to 8,
Okay. Yeah.
Is Registack still around? Is that a good one to
Yep.
use?
Oh, yeah.
It's free. That's something I'm going to probably use.
I think okay, yeah, I'm looking at my icons on the thing there. I think that auto stacker, okay, that does not borrow anything from Registacks. Yeah, that's right. So it's an independent thing.
Okay.
I'm thinking Astrotoaster. Astrotoaster is the one that uses Deep Sky Stacker.
When I get going, I'm going to use an old Canon Rebel and this whatever scope I can get that to fit in, and then I'm going to use Registacks and see what I can do. But I had no idea that you used the video.
The only problem with an old Rebel camera is that it doesn't have the live view, which is of extreme. It's very good for looking at
Focus.
It
at
has
the
live
picture
view.
and being able to focus it and then judge it and
This
all
this
that.
one has a live view, Mike, but it
Well,
it
it does.
doesn't.
Okay, then
It doesn't have the articulated view focus screen. You have to crank your neck around. So
Oh, no,
probably have to attach-
that's not important because you're not going to look at that screen. You're going to look at the computer.
computer, right? Okay.
Yeah.
I'm planning on using an old laptop I got running HP. So if it hasn't melted,
Okay, well, if it's a 32-bit system, you're going to have to use an older version of these of the software.
okay. I'm sure it's 32. I'm sure it is.
Okay, well, that's okay. I'm sorry, Dick, I took over the conversation.
Okay.
Go ahead.
Do you have
Dick.
anything more to say?
No, I just was kind of wondering what support stuff and that I would need to have too. And I got a basic idea, but the book I'm reading now is not real. It's very generalized. It's got a lot of very good information in it, but it's fairly general. It doesn't give you, let's say, a step-by-step. Here's this is what you do.
What book is it?
It's an astrophotography book. This was the one that Jan suggested that I get. It has some pretty important information in there about various things, which I found it to be very interesting.
Mm-hmm.
One of the things that the guy talked about, is the green channels distortion that a lot of people get with planetary nebulas, where they turn out to be all green. And in fact, that's because of the photosites being dominant in the matrix. And in fact, most of the time when you see that, let's say oxygen, O3, it turns out to be green. Well, in fact, it isn't green, but blue. So that's in that book. And that was one of the things that I found out. That book on cosmology that I mentioned to you, Jerry, you've got a copy of it, I think. If you look at the pictures in there, that are not false colored, you will not see any green whatsoever in any of the nebula pictures or any of the galaxy pictures. And the reason for that is the same reason why the sky is blue, Rayleigh scatterings, is that it goes to the higher frequency of light. And so therefore, when you look at some of these nebulas, let's say like the Greater Nebula in Orion, when you look at it through the eyepiece, it looks green. And in fact, that's green channel distortion in your eye. And it's in fact blue. What you're seeing is actually really blue. So that's covered in the book. And I thought that was very interesting.
Yeah, I'll have to look at that. I haven't come across that part yet.
Yeah, I'll go get that book and you guys can keep talking. And
Yeah,
I can tell you which one.
what Dick should do is there are a lot of videos, YouTube videos on these various like Registax and AstroToaster and AutoStacker that I've looked at that's helped me. And you just have to experiment with by yourself, and go through a few mistakes. But basically, most of these programs are really good. The other thing I would do.
That's it. By Theory Legal. He's a French dude, I think he is.
Oh, yeah.
It's a great book.
He taught a workshop at one of the AIC conferences I was attended.
Oh, okay. It's kind of like, I would call it a handbook.
Yeah.
More than a step-by-step procedural thing. If you're looking for that, you're going to have to go somewhere else.
Yeah.
But there's a lot of valuable information in here, and that was one of the things that you brought out about the green channel distortion.
But anyways, Dick, there are a lot of videos on the Registax and the AutoStacker that I was telling the other guys.
Okay.
And so I believe Woodland Hills Camera has some videos that Christopher Go was talking about using this software, and it's online. It's you just go to their website or just ask for the link. But they've been having videos. But Christopher had like 2 or 3 of videos, and he uses, I think, the Registax, and he does he's like a Tony Hallis in a way. He does things very simplistic. He's found a very simple method of doing it, and he's sticking to it and getting fantastic images.
That's what I like, a method.
I got to cut out, guys. I'm going to
Okay.
rest the knee. I'll see you guys next week for sure. Yeah, I mean,
Right.
I enjoyed it all. Hey, Bruce, how you doing?
Hello.
All right, I'll see you guys next week. Thanks a lot, guys.
Okay, we'll see you. Let me give you an update on my 10-inch f3.375. I'm going back to a sphere.
Going back to what?
A sphere. I'm making it. I'm
Oh,
making
the
it
sphere,
more
yeah.
spherical, and I've already got rid of the weird hump at the 80% point, and I'm working on the turned edge. So you know, it's one of those things where doing all sorts of weird things just didn't help. It made things worse. And it's very hard to control. We're at actually it's about 85% point where you got a big spike, the hill, and right next to it is a canyon. Okay, it's very difficult to get rid of. So I just did center over center, third stroke. And so it's taken some of the parabolization out of it, but it's gotten rid of some of the astigmatism and the other bad stuff. So I'm reducing the turned edge now. I can see it. I've gone back to rocketograms because it's, that's a simpler test to set up to get going real quickly. So that's where I'm at. So I probably got about maybe 3 or 4 nights worth of work, just working things down to where I get my edge back to where it's supposed to be.
Okay.
But we've been through that before, and there's.
Have you made
No, well,
any
this
progress? Have you made any progress since you last showed us pictures of your mirror?
I did, but it's no longer valid. It's I didn't download it to my computer, but basically it's looking. I'm just taking walkie-grams. I'm not doing bath because it's not worth the trouble.
Okay.
Because I'm basically what I'm working on is the turn down edge. Once I get that done, I'll go back to the bath. Because
So Bruce, what did you want to ask?
Pardon?
Oh, Bruce and I started speaking at the same time.
Yeah.
Did you want to ask something, Bruce?
No, that's not important. I was just wondering if this was the thin piece of the thing that made out of a porthole, or is this the thick piece of glass?
This is Tom Whittemore's gift to me. He didn't want to. He got tired of working on it and just wanted to do other things. So he gave me basically a complete telescope with a mirror that was incomplete. I used the mechanics for my 10-inch, but then I said to myself, I want to finish off this 10-inch mirror. And I got it really close, and then I screwed it up. And now I'm, I'm looking for redemption on an optical surface.
Now, will the focal length remain the same, or are you going to change
Pretty
that?
much the same, yeah. F3.375. It's very short. And what's really great about it is that it's so short that like in the Rio Vista winds, it's not going to act like a sail. It's very stubby. So if I can get a 10-inch mirror looking really good, and just you use a shorter wide angle eyepiece, you get the same view as a f6 10-inch, with a longer focal length eyepiece, if things are done right. I mean, granted, the ultimate contrast is not exactly the same, and you're losing a few more percent in light, which you really don't notice, I look forward to using it as a public outreach scope, and I'll be putting it on a stand. And one thing nice about it is that the range of motion of the eyepiece is very small. And so you don't have to worry about people being on their knees on the ground when you're looking at a planet, like with a Dobsonian. So it's the closest thing to a Naismith mount when you think about it. So,
Yeah, but an azimuth has an awful big central obstruction.
yeah, I know. Well, this has got a smaller one, but it's it's a short telescope. It's got a 3.5 inch, diagonal, but it should be okay. I think it's probably going to be more limited by seeing than by the imperfections once I get it going. The only critical thing is with a short focal length telescope like that is making sure your alignment stays proper no matter what. And so, but if you took a look at the instrument, unfortunately I don't have a picture to show. It looks like R2D2. It's really short. The cage, and the box, the Sear truss tubes are about this long, and you got the top part's this big and the bottom part's a little bit bigger. So it's very rigid. So it shouldn't be that bad. And another thing too is if I get this done really good, I might try another short focal length telescope like that, in the like f3.3, and use it for astrophotography for a very fast wide field telescope. I got my 410C, which is a full frame. That would take quite a wide field of view. Some of the larger nebulas and stuff like that. For the smaller stuff, I got the C11, so it doesn't matter. But for the wide field, a lot of it is nebula and it's dim and you're fighting with signal and noise, getting enough light on an exposure. So we'll see. It's part of my grand plan of, I'm not stopping at this one or the 14-inch. I'll be making other ones. A future project is another 8-inch telescope, an f8 with a clear window in the front and a tiny diagonal for planetary. And so I have that glass laying around, and I'll make that, and we'll see, how good a Newtonian telescope compares to a refractor. It's just a bunch of projects.
Let me ask Dick a question. Is your book first or second edition?
Well, let me see what I got here.
The important thing is it's still published.
Yeah.
Well, that was my next question.
Well, I got it. Let's see here what it says here. Original 2013. I don't see anything about first edition 2014, third printing 2018 is what I got here.
Okay, so it's the first edition.
Yeah, first edition, third printing.
I just sent everybody here the slides he presented in 2015 at the AIC.
Oh, yeah.
So they don't have a lot of text with them. There are a lot of cool photos, but they have some text.
Yeah, he does some really outstanding stuff in here. Of course, he uses a lot of CCD, so you get the weird haloing effect as a result of that. Because when he goes way back on this stuff, and that CCDs were the only thing that they had at the time that were worth a darn. And but still, there's an awful lot of really good imaging that he's done with this guy. You know what I found fascinating is his imaging of the ISS, say going across the sun or the moon. And to sequence all that, you got to know what you're doing. It doesn't last very long for one thing. And then to make it so that you get like a almost still version of it is another thing entirely. He's got pictures of the space shuttle docking just before it docked and after it docked. Yeah, and stuff like that. It's just wild. It's neat kind of stuff.
Okay. So you're still in the mirror making business, Mike?
Yes, I am, as long as I've got cerium oxide and I get hold of abrasives, yes.
Has anybody, is there such a thing as an automatic grinding machine?
Oh, yeah.
Oh, really?
They've been used since the 20s.
Oh, okay.
Actually, probably before that. Yeah, it's a whole different way of doing it than we do.
Yes.
We do it by hand and strokes. When you do it by a machine, you use a ferocious amount of grinding material, grit. It's not like we put a charge on and we go until the sound change and then it's all off and we wash it off. You're just adding grit continually to it. And then you start adding the next grade to that first grade once you're where you want to be. And it just slowly replaces that nice smooth transition. But it's very inefficient in terms of grit usage. Yeah. But it comes out very nice. You can, people that do it a lot, it takes a lot of experience to do it, in my view. People that do it, you can come right to, it's the only way to do it if you're going to commercially produce something, because you can get right to the focal length that you want. And we don't pay much attention to the focal length. We sit around and we make, say, an 8-inch f5-ish, and if it's in there between 4.8 and 5.2, that's great. But if you're trying to make it something to a design, then there's tolerances on the focal length of each component, and they have to be really tight. If you're not too tight, if you're ish, then the thing is not going to work very well. Okay. So it's a whole different ballgame. And then you need to grind things with a machine.
Also, the figuring is different. The figuring's different. You go to the weight.
No figuring by machine.
Okay. You go to the weight optics, and he shows you how he works on the mirror, making a parabolic. And it's a lot different than what we do. He uses small laps, and because it's a machine, he can dial in closer and closer and closer to the center while getting the proper parabolization. And I think I got into trouble with the 3.3 because I went to his site and I was thinking, I can do what he does, work on the zones with a small one, and it doesn't necessarily work out.
We tried to do machine parabolized mirrors, larger mirrors, 16-inch, for a series of Dobsonians that they made, Star Masters or Starlight or something. And they're very poor mirrors. They have when you machine, a machine doesn't vary. A machine reproduces itself exactly. And what you depend on for a really good mirror is the sloppiness of the human hand, that you can't actually repeat your stroke. You average out all the things that are happening. And what happened with Mead's mirrors, by the way, you can buy Mead mirrors on the different forums like Cloudy Nights, and they're plate glass, but they cost you less than the raw blank costs for the finished mirror. So it's a cheap way to get a good mirror that all the grinding has been done. You soak off the coating and then you repolish it to a sphere, and then you start hand figuring it. You can get a good mirror out of it. But the pattern it comes out with is like radial petals. It's like waves that go around the the mirror as spokes. And that, because the machine just repeats itself, it has patterns, and it's so hard to break that pattern. So that there's not a lot of commercial product out there that's any good. Now, when I worked at Santa Barbara Research Center, we had our optics made by machine, but the method there was ion milling for the final polishing and figuring. So there was no grinding or tool of it. It was a beam, and the beam can be very well controlled. There, with some glasses, you can do what is it? Lathe work, diamond turning. That's what it said. And you can diamond turn the material. Not every material will respond that way, but a lot of the glasses we work with will. They'll diamond turn to a very nice finish, and then you ion mill to get rid of the last vestiges of roughness and subsurface fractures. But you can actually ion mill it, or not ion mill it, diamond point turn it to within a quarter of a wave of a true parabola. But there's a lot of fractures that propagate down into the glass, and you need to do the ion milling to melt those fractures out, and then you get the really fine curves. That's how a lot of big optics are made. Some of them are still
So
made.
it's ready for aluminization after the ion milling?
Yes.
But
Wow.
it probably cost about $10,000 to $50,000 for a 16-inch mirror.
It probably would.
Jeez.
So we
Is that
had,
what those planet wave things are, or are they doing something like that, or
what's that?
didn't they call them planet wave, or what the really good optics that you buy? I suppose they must do something like that.
I don't know. I think that the really good optics are the very expensive stuff. I think they're ion milled at the end to give them very fine hundredth of a wave and stuff.
Or they're done the old way, like at Royce Optics.
You want to do that with long wave. If you're going to use short wavelength light, you've got to get a really, really high performance mirror. If you want to do infrared light, you don't have to be as exact. And for example, the spacecraft that I was involved with making, they almost uniformly make their mirrors out of beryllium. And the beryllium is machined and then ion milled, and then it's coated with nickel. And that's the optical surface. And they make it out of beryllium because the entire rest of the frame of the spacecraft is also machined out of beryllium. And that way it has the same
Coefficient of expansion.
Thank you. Thank you, Bruce. My senior moment there. So it didn't distort as the whole expands and contracts with the same properties.
Does anybody have any experience with amateur versions of adaptive optics? Let's say SBIG's stuff.
SBIG made an adaptive optics thing but it didn't, adaptive optics, it has what they call a rubber mirror for the secondary, and they distort that mirror to take out, the SBIG stuff didn't distort it. It just had a solid flat mirror, and it would move the mirror and take out the gross motion due to very bad seeing, but it didn't correct the wavefront at all. And I'm not aware of anything for the amateur that does a wavefront correction. That would be extremely expensive. I'm guessing.
Yeah.
Whatever happened to SBIG? I think they got bought by Software Bisque or something, didn't they?
Oh, okay.
Eventually, I know that they got bought by an entrepreneur in San Francisco because he showed up at some imaging conferences with a SBIG badge on, and all the experts stayed down here when he moved the company to San Francisco, and they sort of disappeared.
I think it's part of cyanogen, isn't it?
I have no idea.
And they were the ones that invented that ST4 standard, weren't
Yes, they made the first cameras for amateur use and professional use.
Actually, the first two were local. It was SBIG, and it was also, wasn't photometrics, it was I'm having a senior moment, but it was local. They were in Newbury Park. and they were
Okay.
competition. They were using the same chip, the TC211.
Yeah.
And,
Now, SBAU's bigger climate was the guy that ran it always loved astroimaging, and so he was doing for the telescopes. But they had a much bigger market in doing it for microscopes, for pathology and doing medicine through microscopes and imaging, and then machine language, where you're, or machine imaging. No, I forget the machine something, where you're looking at parts that are being produced on an assembly line, and they're going, we want them to go by so fast that only the machine can see the flaws in them. So they had a very big market in that.
Yeah. Yeah, they talked about that in this book here, the SBIG stuff and the adaptive optics. Okay.
There used to be a thing where we had spectroscopes available to amateurs. It was an eyepiece with a set of 3 prisms in it or something that were counterstacked. So you look straight through and you could see actually a spectrum of a bright star. And I was always interested in doing spectroscopy, but I don't know of any things that I'm willing to spend money for that are in my price range.
Yeah, you know, and the other thing too is that a lot of that stuff is done photometrically now.
Yeah.
So there's not so much, you know, the old traditional spectroscopy done nowadays. It's mostly done photometrically. So
That's
Well,
okay.
I've seen things where they use a ruled grating for the secondary, so you get the images of all your stars smeared
Yeah.
out by
Yeah.
okay, I actually have the copy. Oh gosh.
It's not focusing on that.
There it is.
Okay,
Back
hold
off.
a second. Let me. I'm trying to. Okay. Okay, this is the October 1990, and in it is an article written by yours truly on. Oops.
It's not
CCD.
focusing. I can't read it.
Okay.
Oh, CCD cameras, digital astrophotography is here.
Me.
Yeah.
Okay, so that was my 15-minute of fame. And okay.
Hey, you've got 14 minutes and 30 seconds to go here.
Yeah, okay. It was Photometrics was the other local people who did it. But anyways, I went to the VCAS meeting on Saturday night. I visited my mom, and they had this guy that was talking about exoplanet exploration from JPL. And one of the key points that he had was that a lot of the co-authors and a lot of his papers are amateurs with scopes in the range of 4 to 12 inches, most of them under between 4 and 6 inches, taking photometric data on exoplanet stars and using what is called the exotic software, which is free, and the data is given to the AVSO, and the AVSO gives it to people like him to study for exoplanets. And so their idea is to get amateur astronomers into this thing so they can get better reduction of the orbits and the likelihood of crossing, so that they can spend time on the Webb and the Hubble and Earth base in a more efficient way. So again, it's using imagers like our DLSR and inexpensive cameras.
You know, 6 years ago, we had an amateur junior high girl named Zoe.
Zoe, yeah.
That measured exoplanets by occultation across the star with her DSLR camera, I think 135 millimeter lens.
And it was on the barn door tracker too.
Yeah, yeah, she did a wonderful job.
Yeah.
So the value of amateurs, I think, is not the sophistication of their equipment. It's just how many of them are, because there's so many targets to look at.
And so the secret for people like us is that we have our main telescope, but then also we have this other telescope that we can use all the time for other stars, and it doesn't tie up our main instrument. And he was saying that you only need the average dip is about 1% or something like that in light, and that's good enough to get usable data. So I thought to let you guys know about that. He probably would come out and give a good talk to you guys about that.
What's his name again? We've had two talking about exoplanets here recently.
Okay, let me, it's on the VCAS website, and it's Zellman or something like that, I forget. He's a relatively young guy. Well, for somebody of my age, anybody's relatively young. But
You're young. Compared to me.
you give me a moment, go ahead and start talking, and I'll find out here a second.
Okay,
Can I interrupt here and
go ahead.
see? Oh, Dick has left. I got my auto guider working, but when my auto guider works, my main camera will not work. I did it both two different ways. That is, I did it the standard ST4 cable, and then I took the ST4 cable out and I did it what you'd call direct, I guess. And I got the same results. I got the camera to lock on. I got the mount to say it's mounted. And then generally what happens is it does looping, and it says signal to noise and loses star. I tried adjusting the gain. I don't know if I adjusted it the wrong way or what, but I didn't get any better results. And then I tried to change the time limit on when it takes exposures from 1 second to 3.5 seconds. I don't know, did you miss that, Dick? I got the on camera to work for the auto guider, but the main camera will not work when the auto guider is working. There are some functions I can do with the main camera. I can change the time and I can change the gain, but I can't get a picture. I cannot record anything. And if I look at the histogram, it's dead. And then the only way I can get a comeback is to turn everything off and bring everything back up. Now, I read on cloudy nights that a guy had a similar problem back in 2014, and then more recent in 2021, several guys have had problems where the PhD basically just turns off in the midst of whatever. They're confounded. They don't understand why. And then somebody suggested that, oh, why don't you try fire capture instead of the ZWO program? And I have not done that yet. But I don't understand why I get this signal to noise thing is out, and why I can't get good accuracy. Oh boy, I can't talk. Accuracy, acquire a good star.
Okay. So if you try to use it standalone without the other camera, you're okay. And then when you try to put the ZWO camera on there, then it fails. And when you're trying to run two cameras at the same time.
Well, the two cameras, the second camera is the auto guider camera.
Okay.
So I'll start out with the main camera. I can do whatever I want to do. I start up the other one and I get connected with both the camera and the mount. And I go into looping. Looping seems to work. And then one time I went into direct search or auto search, excuse me, the auto search, and that seemed to work. And then it all of a sudden says, and it displays a signal to noise number, and then it says star is lost. And,
So you can go in there and you can select the star, and it'll show you, you know, that you've got enough signal to noise ratio down at the bottom. And you
not,
can see where it goes around the star, right?
not exactly. What happens is I see on the screen what looks like one star, and it's an auto search. And that's all I'm seeing is like one little, it almost looks like one pixel or something is screwing up. Go ahead, Mike.
Question. With the auto guider chip, the camera, in this program, can you actually see what it sees? In other words, like in PhD guiding, you always get a picture of what it sees, and then you know you always click on the star you want to do, and it puts the crosshair there, and it does its thing. When this happens, can you actually see a picture of what the chip is seeing or not?
I'm not sure. I'm seeing what looks like one star, and it's very small.
Now, can you run, have you tried to run just the auto guider by itself without running the other camera?
No, I didn't know if I could even do that, actually.
Well, one would think you could. It's a standalone camera, right?
Yeah, yes.
So I would try that first, and then at least you'll know, oh, geez, I got an interference problem between the two programs, and then you can work it from there. Because you might be fighting, you still might be fighting another problem here that has to do with that interface. So I would get that straightened out first, do your loop like Mike said, and then you should be able to see multiple stars on there, you know, that you could choose one of those stars. And then when you're ready, then what you can do is you can put the cursor on, let's say, a star that you think is bright enough, and down at the bottom, it should show you the signal to noise ratio. You're probably looking for a number that's about 12 or greater. You don't want to go too bright, because if you go too bright, then the point spread of the star will be such that you might not be able to get an accurate centroid.
You know, it seems like I got a much larger number, 78, 80.
Oh, that doesn't seem right at all.
That doesn't
Oh, it
sound
doesn't
right.
seem
Hold a
right at
second.
all.
Is that out of 256?
Oh, I was thinking dB. Okay.
Well, no. These normally are the numbers like with PhD guidance between
It's
0
linear.
and yeah, it's linear. It goes between, because it's assuming an 8-bit intensity value. So, you know, like 70 or something like that's, you know, like about 1/5 full scale. But the thing is, what I would do is run PhD guiding, and you first have to do a calibration to make sure that once you select the star, it's able to calibrate out it's X and Y, but it might be turned one way or another because your camera needs to be adjusted, rotated for the axis. Okay, this axis and this axis. And
Never noticed that mattered with my using it. It would always sort out. It would say I'm going to move.
Yeah.
Move to the
I
left.
always try and get it strictly orthogonal.
Yeah, but that's just aesthetics, I think. I don't think it's this fundamental problem. Let me ask you, are these numbers noise, are they growing as you watch them? Maybe you have some kind of accumulated loop or like addition loop going on that's causing the background noise to grow and then obscure the star.
I think it might be growing. Yes, it seems like jumping around a lot, but generally growing. Yes.
It doesn't seem right. Something ain't right.
What's that, Nick? Dick?
I would say something is not right, because when you put that thing in loop, you should get an image of the stars that are out there. Now, do you know that whether you're in focus or not? And there's a few things there that you may not be in focus, although I can't quite figure out why you would have a bright light in there. Then
Maybe it's a hot pixel.
Oh, yeah.
It's
I need
that-
to check the focus again. I've checked the focus and before, and I was right on. But I
Okay.
also get after it times out, it says, okay, in 16 seconds, it didn't find a star.
Yeah, couldn't
Not
find,
buddy.
what couldn't it find?
A star to,
Okay, couldn't find a star, and you tried to select one, but it didn't work, right?
right.
Okay.
Huh.
And all you can see is what looks like maybe one bright star. That doesn't seem right, you know.
No,
it's-
that
What's
does
that?
not,
That's a hot pixel.
it might be.
yeah,
Yeah.
but it'd have to be a real hot one. For
It would have to be a real hot one,
Yeah,
and how
because,
come I
mean,
don't
if
see
you're
it on
only
the
doing
main
like
scope?
1 second exposures,
Or,
I don't think a hot pixel is going to even, if it's less than a
Oh.
second.
Well, one thing that would fix that is most of these programs tell you, or at least have the hooks for you to take a dark frame and subtracts out any of the hot pixels.
Yeah, but
Yeah.
if you're using 1 sec, less than a second or less, you shouldn't need to worry about that. The
No,
exposure
no.
is so short that you're not going to need to do noise reduction with the dark frame. It does have that capability in PhD, but I can't really see using it for a high focal length instrument because you're going to get too much movement in there between the time that you'd be doing your sampling.
I did do a dark frame set the very first time. It sent me into a dark frame set, and I did that. I kind of screwed up the rest of that night and returned the next night.
You know, I think a second, I think that's about what I use on mine. Now, of course, if your machine isn't fast enough, I might not be able to keep up with it, but 1 second seems pretty adequate for me for sampling for just about any of the instruments that I use.
Actually, I wind up using about 3 to 6 seconds.
Okay.
And
I think
for
they
me,
recommend
that
that
takes
you
out
use
the seeing issues with seeing, so that it doesn't try and follow the scene. But that's just my setup here.
Mhm.
I think they recommend 1 second or more. That's a good
Again, you're
idea,
using
Dick. I'll
what-
try the auto guider.
Again, you're using what? The system that you're using what software with your auto guider?
PhD.
PhD, but with a
ZWO camera.
Oh, yeah.
But are you using it with a computer, or are you using it with one of those little Unix boxes?
I got a laptop.
Okay.
Okay.
Yeah, I would run it with PhD by itself just to make sure that it runs properly and that doesn't. One of the things is losing bad signal to noise ratio could mean that it's telling the mount or not telling the mount to move, and it's moving off of where it's using a region of interest out of your picture to look at the star and move it around, okay, the small region of interest. And if your mount goes off outside this region of interest, I think you'll get into a signal to noise ratio where it's just off and it's looking at noise instead of a star.
Well,
But-
once the auto guider takes over, I should not have any control on the motion of the telescope and the mount.
You do not touch the controls, correct?
Yeah.
But the thing is you have to do a calibration to make sure, for example, that you're telling it to go right or left, and the way things are hooked up, that it actually does it there. I mean, in some cases, special cases with certain mounts, it's the exact opposite. So you just need to make sure that you're telling the mount to go the way it's supposed to go. I had that happen once.
Yeah, if it doesn't move, if the software tries to move the mount to calibrate how much control it has, and something doesn't move, then it will give an error message. And usually it's a clutch that's slipping or a gear that's disengaged or something like that.
Or the cable that goes to the mount is bad, or
Yeah,
that's
something like
happened to
that.
me.
Yeah.
Or can't move it. So,
Yeah.
you know, it sounds like to me though, you're before that. You got a problem before that. You're not even getting an image out of that camera. So I would definitely try just try the auto guider by itself. Don't worry about connecting the other camera up yet, and try to get that going. If you can get that going by itself, then you know you've got some kind of a weird interactive problem between the two cameras, that one is confusing, say, the other one somehow, or using the same buffer or something like that. So it's not going to work that way.
Excellent idea. Very
Yeah,
good.
try that. See what happens.
Good luck.
And then what you do with PhD guiding is you look at you click on the graph icon and just look how it's guiding, and you'll see how the corrections are going.
Yeah.
Yeah, that trender is really a good
Yes.
thing to use. I use the trender all the time when I'm auto guiding, because you can look at it, and what's nice about it is it'll show you what's happened in the past for a certain portion. So you can come out there and you can go, oh my gosh, yeah, I got this problem. When you become familiar enough with it, my main deal is RA oscillating. And that's because what's happening is it's rocking on that slop and that worm gear.
Yeah, if you get an oscillation set up, you've got to change your exposure time, because you've got to change your, and they call it the attack.
Yeah, or
Yes.
weight the mount, you know, slightly off weight the mount,
Yeah.
so that it stays on one side of the gear.
Yeah.
Versus the
But
other.
it's part of the it's part of the calibration. And another thing too is you got to go in there and tell it what your focal length is, and the pixel size, because it uses that as part of the calibration. And actually, PhD guiding, the new one, will tell you, oh, well, you should be using this. You know, it actually throws in the numbers that are optimized for your mount. At least the new version does.
I've entered that, the focal length and the pixel size.
Yeah. Yeah, we'll try it by itself, and then at least you'll know, okay, well, we got a problem here by itself. We don't have a problem with it interacting with the other camera.
Mm-hmm.
Right now, it seems like it's interacting with the other camera.
Yeah, that's what it seems like to me.
Might actually look at your main camera instead of the auto guiding camera.
Yeah, or it's confusing one buffer that's being used by both of them.
Yeah.
For some reason, it just, you know, and there may be things that you can do, you know, like reassign things within the program so that it uses another cache or something like that.
So what program are you using for acquisition along with this PhD guiding?
The ZWO program. I don't know what they call it. But somebody suggested in the Cloudy Nights that had a problem to try fire capture. And then there was no response back as to whether it worked or didn't work. So I don't know. I'll try that too if I can't get anything going.
Yeah.
But somebody early on had pointed out that, matter of fact, with the ZWO 120 and the ZWO 130, that they had issue problems guiding.
That's right. I remember that.
Sorry?
I remember reading that in Cloudy Nights ad you looked at one.
Yes. Yeah.
And that's what I bought for my.
Well, we'll refer to Ed to get out of the trap then, as soon as he solves it for the rest of us.
Okay.
Okay, well, I think we're at the end of our appointed time.
Yeah.
Does anyone have anything else earth-shaking to cover? Or shall we adjourn until next week? Okay.
Yeah. Goodbye.
Good night, everybody.
Good night.
Good night.